In a test of 2000 electric bulbs, it was found that the life of a particular make was normally distributed with an average life of 2040 Hz. Average life is nothing but mean value, that is mu value. Mu equal to 2040 Hz, and standard deviation is 60 Hz. Now we are asked to estimate the number of bulbs likely to burn more than 2150 Hz, less than 1950 Hz, and more than 1020 Hz but lesser than 2160 Hz. This is the terms we have to calculate. Given as usual, mean mu equal to 2000, mean mu equal to 2040, and standard deviation 60. Simply substitute mean value and standard deviation sigma value in standard normal variate formula. Then this is basic fit of standard normal variate. Now we have to calculate Z. This value is nothing but Z. This entire value. This entire value is nothing but Z. Okay, this entire value is Z. So probability of Z greater than, first question. What is first question? First question, 2150 hours, more than 2150 hours. So simply substitute the 2150 in place of X. In place of X, you put 2150 hours. 2150. So substituting 2150, this is the term we can get. So probability of Z greater than 1.83. Probability of Z greater than 1.83 is the term we have got. So now by referring normal table, we have to calculate the area for 1.83. So last that single digit refers to column, and remaining this one 1.8 is nothing but row value. So 1.8 row and third column, 1.8 row and third column is see, where is it? 1.8 row and third column, 1.8 row, and this is 0. First, this is 0th column. First column is 0th column. Therefore 1.8, 0th column, first column, second column, third column. So 0.4664. 0.4664 is the required value for this problem. So simply substitute this value 0.4664 here. Then simply substituting 0.4664 for X, Z is greater than 1.83. Therefore 1.83 lies in the positive side of normal distribution, sorry, normal curve. And we know that its right hand side, entire right hand side value is 0.5. So 0.5 minus area lies between these two ordinates. Then 0.5 minus 0.4664, that is 0.0336. Now for the lot of 2000 bulbs, simply multiply this probability value with 2000. Therefore 67.2 approximately. These are all based on quantity 67.2. That 67.2 is nothing but 67 bulbs. And to calculate second sub question, probability of X less than 1950. Simply substitute 1950 in place of X. Therefore we can get probability of Z less than minus 1.5. So this is the area, probability of Z less than minus 1.5, is it not? So probability of Z less than minus 1.5 see, probability of Z lies probability of Z lies less than 1.5, the area less than 1.5, pen, okay, minus 1.5 here, minus 1.5 somewhere in the left hand side of 0. Then Z is lesser value means this area goes left hand side. So this is the portion we have to calculate. This is a portion we have to calculate. So to calculate this portion, this entire area as usual 0.5. This entire area 0.5. Therefore 0.5 minus area lies between these two. Being this normal curve is symmetry. Normal curve is symmetry. Then this minus 1.15 less than z less than 0 can be written as 0 less than z less than positive 1.5, because the same area, this side whatever the area, the same area, if we note positive 1.5, if we note positive 1.5 here, the same area we can get. Okay, but therefore this is 1 point. Okay, 1.5, then 0.5 minus 1.5. So 1.5 means 1.5th row, 1.5th row and 0th column. 1.5th row and 0th column is the required normal area for this problem. Okay, so 1.5 and 0th column we are going to 433 2. Okay, well, see here, referring normal table, 1.5th and 0th column. See here, 1.5th row and 0th column is 0.4332. 0.4332. Simply substitute this value in this problem, then we can get 0.5 minus 0.4332. Therefore 0.0668. Simply substitute this value with the frequency. I mean the lot is given of 2000 bulbs. Simply multiply this probability value with 2000, then we can get approximately 133.6. This is approximately equal to 134 bulbs. 134 bulbs. And how to calculate third sub question, that is probability of x lies between these two values. X lies between these two values, and I hope that hereafter you can understand better how to refer the normal table. How to refer the normal table. So this is the value. Simply substitute 1950 in this place and 2160 in this place of standard normal variant. Therefore z lies between minus 2 and plus 2. This is z lies between minus 2 and plus 2. That is twice of, as this area is equal, twice of probability of z lies between 0 and 2. Z lies between, because normal curve is symmetry, no? Normal curve is symmetry. So therefore this area equals to this area. So twice of, 2 into probability of z lies between 0 and 2. But now we have to calculate the area value, normal area, by taking 2 as row. 2 is row and 0th column. 0th column. So second row, 2th row and 0th column, that value is nothing but already we have seen 0.4772. Simply multiply this value with 2, then we can get the probability value, and multiply this probability value with this 2000. This is nothing but given lot, number of bulbs. Simply multiply this quantity with the number of bulbs 2000, then we can get 1908. This is approximately equal to 1909 bulbs. 1909 bulbs are there. Next problem, the local authorities in a city installed 2000 electric lamps in streets. If the lamps have an average life of 1000 burning hours with the standard deviation 200 hours, what number of lamps might be expected to fail in the first 700? After what period of burning hours would you expect that 10% of lamps would have failed and would be still burning? Assume the lives of the bulbs are normally distributed. This is also very simple. Substitute given mean mu value equal to 1000, sigma value equal to 200. Substitute this mean mu value and sigma value in standard normal variate. And first question we are asked to find x less than 700. Simply substitute this x equal to 700 here. This is nothing but the value here. That is probability of z less than minus 1.5, and this can be written as probability of z greater than minus 1.5 because of symmetry. Because of symmetry, this is 1.5. Okay, 1.5. So therefore this entire area 0.5 minus the required probability value p of 0 less than z less than 1.5 and 1.5. How to calculate 1.5? 1.5th row, 1.5th row and 0th column. Okay, 1.5, because 1.5 is available in the table. 0th column. This value is nothing but 0.4332 referring the normal table, and subtract this value from 0.5 and simply multiply with the 2000, then we can get 133.6, that is approximately 134 bulbs. And next, for first question, let x1 be the period after which 100 bulbs would have failed. That is x1. We don't know what is x1, what is the period. So we simply assume x1 is the period. This 10% is nothing but this 0.1. 10% is 0.1. Therefore, this value is nothing but z value. This is z value. Okay. Therefore, this z value is less than x1 minus 1000 divided by 200. That is probability of z less than x1 minus 1000 divided by 200 equal to 0.1. Keeping the term here. That is probability of z greater than 1000. You see, less than, by using symmetry property, this can be written as x1 minus 1000. Therefore, if you simply multiply this with minus symbol, then probability of z greater than 1000 minus x1 divided by 200. That is, this z is greater than means 0 less than z less than 1000 minus x1 divided by 200, because z is greater than this x1. Z is greater than x1. So therefore we can get a 0.5 minus the area lies between this case. Therefore 0.5 minus probability of 0 less than z less than this value equal to 0.1. So you take this 0.5 to right hand side, 0.5 to right hand side, and adjusting the matter, probability of 0 less than z less than 1000 minus x1 divided by 200 equal to 0.4. And referring the normal table 0.4, this is 0. Referring the normal table in reverse order, in reverse order. So referring the normal table in reverse order, this is very important and different formula, different problem, because for this type of problem we have to refer the normal table in reverse order. Therefore referring the normal table in reverse order, then we can get the ordinate is 1.28. How to find out ordinate is 1.5? This is 0.4, no? So 0.4. Simply see, I shall see its normal value 0.4. So where is 0.400 occur? You simply see 0.39. So you see 0.8. This is 0.2190. 0.2517, 0.2823. So we are going to refer the normal table in reverse order. We are given the area for which we have to calculate the ordinate. So 0.399. You see 0.3997 is nothing but 0.4. It is very near to 0.4 only. 0.4. So this ordinate refers to 1.2. And see here what column, 1.2 and 8th column. So 1.28 is the required ordinate for this value. So cross multiplying and adjusting the term, we can have x1 equal to 744. And similarly Let x2 be the period after 10% of lamps would be still burning. See here, probability of x greater than x2 equal to 0.1. As usual, probability of z greater than x2 minus 1000 divided by 200 equal to 0.1. That is, I mean multiplying using symmetry property, adjusting the term x2 minus 1000, x2 minus 0 less than this value. You see this value, this value, and this z is greater than this value is symmetrically plotted in this normal table, but therefore this can be written as 0 less than z less than x2 minus 1000 divided by 200. That is equal to 0.4. Okay, I mean here you have to note here 0.5 minus of this value. That is what I am coming to explain you now. See here, this is the value. Therefore, to calculate this area, we can write it as 0.5. 0.5 minus this probability term. This probability term is simply, I note it as P. That is equal, this is P, that is equal to 0.1. So take this 0.1 this side and taking that this probability function to right hand side and rearranging the term, then we can get this entire term. This entire term, probability of 0 less than z less than x2 minus 1000 divided by 200 equal to 0.5 minus 0.1 is nothing but 0.4. So 0.4 is, as usual, 0 by referring the normal table in reverse order. 0.4 is the area. This 0.4 is area. The same for previous problem also. This 0.4 is the area. So approximately 0.4 area, 0.4 level of area, we can get the ordinate 1.28. So cross multiplying and adjusting the numbers, then we can get x2 equal to 1256. So this is the answer for second question. After 1256 hours, 10% of lamps would be burning. Okay, and we shall see another problem. This problem is also very important. In a normal distribution, 31% of the items are under 45 and 8% are above 64. Find the mean and the standard deviation of the distribution. For this problem, we have to calculate mean and standard deviation. And 31% and 31% of the items are under 45 and 8% are above 64. Let mean be as usual mu and the standard deviation be sigma. Given 31% of the items are under 45. So you see, this is probability of x less than 45 equal to 31%. 31% is under 45 means probability of x less than 45 equal to 31%. This is 31% under 45. Okay, and probability of this is nothing but z value, z less than 45, this value, this is nothing but x value. Okay, x value. So x equal to 45 minus mean mu, because using standard normal variate. What is standard normal variate? Z equal to x minus mu divided by sigma. So if simply substitute x equal to 45 here, x equal to 45. Simply substitute x equal to 45 here, and the mu sigma values are unknowns. These two values are unknowns. This is the term we have to find out. This mean mu and the sigma value are the terms we have to find out. These are all unknowns. So 45 minus mu divided by sigma equal to 0.31. That is probability of z less than 45 minus mu divided by sigma equal to 0.31. That is probability of 45 minus mu divided by sigma is less than z. This can be written as less than z less than 0 equal to 0.19. This is area. Okay, so this is the area. According to this area, based on normal table, we can have 0.19th ordinate, 0.19th ordinate. Okay, 0.31. I am going to explain it. I am going to open normal table. 0 point, what is the value? 0.31. For 0.31 I am going to find out what is the corresponding ordinate. 0.31. 0.35, 0.32, 0.29, 29, 3, 3, this. So 0. 0. See here 0.31, no? So 0.31, referring normal table. Where is it? So 0.87, 0.31, 31 occurs here itself. So 0.86. Just wait, I stop this.